Hello all, I am Dr. Rizvi and this is lecture 2 on simple stress and strain. And in this lecture we will discuss about strain. In the first lecture we have discussed about the stress and various type of stresses. The concept is that when a body is acted upon by an external force P, it generally deforms or it initially deforms. It changes its shape like this. If a tensile force is acted, its length get increased. So from here we can derive that initially the length or the dimension is changed. Whether it will increase or decrease, it will depend upon the nature of the stress or the nature of the force that is acted upon the body. The body initially changes its shape. So the concept is, first the strain is developed in the body and then the stress is developed inside the body to resist that deformation. So we can say that strain is the first thing that is developed in the body when the body is acted upon by the external load. Strain is basically the deformation that is produced in the material that is subjected to external forces. If a bar is subjected to direct load, then due to the load, the bar will change its dimension. And if the bar is of initial length L, if this bar is of initial length L, when the load is acted, the external force is acted, its length will increase, and this length increase, let the total length increase is del L or delta L. The strain that is produced here will be defined or denoted by Greek letter epsilon, and epsilon, that is the strain, will be equals to the change in length upon original length, that is epsilon equals to del L upon L. This is the strain that is produced in the body. After this strain is produced, the body material will resist the action of the external load and the body will become stable. Strain is the measure of deformation of the material and it is a non-dimensional quantity. That is, it do not have any unit. It is dimensionless. No unit. Dimensionless. Talking about the sign convention of strain, when the strain is tensile in nature, these strains are considered as positive because the dimension is increased, and when they are compressive strains, they are considered as negative because the dimension is reduced. Now we will discuss about the types of strains that a body experiences. The first type of strain is normal strain. Normal strain or it is known as linear strain, or it is known as longitudinal strain. All are same. Linear strain or longitudinal strain. They all are same. And sometimes it is also expressed as axial strain. All are same. It is generally the ratio of change in length of the body to the original length of the body. Normal strain is generally denoted by epsilon n, and it is the ratio of change in length over original length. For example, if this is the bar that is experiencing a load P, and it on application of external load, this is the extended length, that is delta L, and this is the original length L. So the change in length will be L plus del L minus L upon L, and it is equals to epsilon n equals to del L upon L. This is normal strain. The second type of strain is lateral strain. Lateral strain. Generally, it is defined as the ratio of change in lateral dimension of the body to the initial lateral dimension. For this, we'll draw the figure first. Let us consider this cylindrical bar that is experiencing an external load P. Let the initial lateral dimension is D, and on extension its diameter will get reduced because its length will increase, and thus the lateral dimension will get reduced, and it will be a somewhat lower value than the initial lateral dimension. Let it be small d. So the lateral strain, that is denoted by epsilon L, epsilon L will be equals to change in lateral dimension, change in lateral dimension upon original lateral dimension, that is d minus small d upon capital D, or we can also write it as del d upon d. This is lateral strain. The third type of strain that is developed in the body is shear strain. Shear strain is experienced when the body is acted upon by shear force, when an element is subjected to shear force, and generally it does not change its length, it changes its shape, and the shear force causes shear deformation. And we can see in this image, for example, if we take this element that is subjected to external uh, shear force, if we fix this. Let us name the sides as A, B, C, D, and tau acts here. So it will change its shape from a rectangle to this. This will be the initial shape, and now it looks like this. A will get converted into A dash, and B will get converted into B dash, and C and D remains same. And the body is deformed through an angle phi. Let this angle be phi, and let the height of this element be h. So we can say that tan phi is equals to d dash, sorry, a dash whole divided by h. Here in this triangle we can say that tan phi equals to perpendicular upon base a dash upon h, or it can be b dash upon h. Both triangles are same. Since this phi is very small, so tan phi equals to phi, and thus phi equals to a dash upon h, and this phi is the shear strain, and it is representing the shear strain that is developed in the material due to shear force that is acting upon the body. There is one more strain that is developed in the body when it is acted upon by external forces, and that is, the fourth one is volumetric strain, and it is denoted by epsilon v. As the name expresses, it is the ratio of change in volume to the original volume of the body. It is the ratio of change in volume of the body to the original volume of the body. That is, epsilon v equals to del v upon v. So in this lecture we have studied about the concept of strain. We have studied the definition of strain, and we have also studied the various types of strain that are developed in the body when it is acted upon by external forces. Thank you.